Hello viewer, welcome to my channel Learn Physics.
व्यूअर्स आज इस वीडियो में हम साइलैब में एक प्रोग्राम लिखेंगे टू सॉल्व फॉलोइंग इंटीग्रल using Gauss-Legendre Quadrature where Pn of z and Pm of z are Legendre polynomials of degree n and m respectively. In Gauss-Legendre Quadrature, integral on left-hand side of equation 1 can be approximated with the term given on right-hand side, where zi are the roots of Legendre polynomial Pn of z, ai are the corresponding weights given below. Using Gauss quadrature, a polynomial f of z of degree up to 2n minus 1 can be integrated exactly. Suppose n is equal to 1, then 2n minus 1 yield 1. So polynomials with degree up to 1, that is z raised to 0 and z raised to 1, can be integrated exactly for one point, that is n is equal to 1. Similarly, for n is equal to 2, polynomials with degree up to 3 can be integrated exactly for 2 points. That is, for n is equal to 2, polynomials z is equal to 0, z is equal to 1, z is equal to 2, and z is equal to 3 can be integrated exactly. Similarly, for n is equal to 3, polynomials with the degree up to 5 can be integrated exactly for 3 points. That is, for n is equal to 3, polynomials z raised to 0, z raised to 1, z raised to 2, z raised to 3, z raised to 4, and z raised to 5 can be integrated exactly, and so on. In Scilab, using Gauss-Legendre Quadrature, integral given below will be solved, where Pn of z and Pm of z are Legendre polynomials of degree n and m respectively. Legendre polynomials can be generated using Rodrigues formula as given below. Here, product of Pn and Pm will be considered as f of z. Now let us move towards the steps to write Scilab program. Generate Legendre polynomials Pn of z and Pm of z using Rodrigues formula and take their product f of z is equal to Pn Pm. Find degree of f of z, which is k is equal to n plus m. Find n using 2n minus 1 is equal to k, which gives n is equal to k plus 1 over 2. Now round up or seal n to nearest integer. Generate Legendre polynomial Pn of z and find its roots zi and derivative p prime n of z. Calculate ai. For each I, sum of the contribution ai f of zi. That is, and in last display result. Results can be verified using orthogonality of Legendre polynomials via equation 3, where delta mn is a Kronecker delta and has values 1 and 0, 1 for n is equal to m, 0 for n not equal to m. Values of 2 over 2n plus 1 can be verified for the case when n is equal to m with the given table. तो चलिए साइलैब में प्रोग्राम लिखते हैं. तो चलिए व्यूअर्स प्रोग्रामिंग स्टार्ट करते हैं. एक फंक्शन डिफाइन करते हैं. A is equal to LP of n. Here Z is equal to poly 0, comma, in single quote we write Z. X is equal to Z square minus 1 raised to n. Z square minus 1 whole raised to n. Now we start a for loop. I is equal to 1 to n. Here we write y is equal to derivate x is equal to y, and now we write a is equal to x divided by 2 raised to n and factorial n. That's it. Now we write n is equal to input Now we write enter. N for Legendre polynomial, Pn of z, n is equal to, now we write Pn is equal to Lp of n, we write mprintf backslash n, now we write P percentage d z is equal to percentage s, comma n, comma pol2 str, we write Pn. Now we execute the code. So n is equal to 0, n is equal to 1, n is equal to 2. So we are getting correct result. So now we copy these statements, paste them here, make the appropriate change, m, 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 pm, lp of m, here mn, in last pm, that's it. Now we write f is equal to pn multiplied by pm, k is equal to n plus m, capital N is equal to Ceil, k plus 1 divided by 2. Now we write Pn is equal to Lp of n, Pn d is equal to derivate Pn, r is equal to roots Pn, s is equal to 0. Now we start a for loop, I is equal to 1 to length of r. Now we write ai. Ai is equal to 2 divided by 1 minus r I raised to 2. Here we write Horner P and D, comma R I. That's it. Now we write F I equal to Horner F, comma R I. That's it. Now we write S is equal to S plus AI multiplied by Fi. Now we write mprintf backslash n integration of P percentage d z P percentage d in the limit -1 to +1 is backslash n percentage f, comma n, comma m, comma s. Now we execute the code. N is equal to 0, m is equal to 0. Again execute the code. N is equal to 1, m is equal to 1. We again execute the code 2, m is also 2. Now give n is equal to 1, m is equal to 2, n is 2, m is 3. So this is how, viewers, we can integrate product of Legendre polynomials Pn of z and Pm of z in the limit -1 to +1 using Gauss-Legendre quadrature in Scilab.
व्यूअर्स, आज के वीडियो में इतना ही। उम्मीद करता हूँ कि वीडियो आपके लिए हेल्पफुल रहेगा। थैंक्स फॉर वॉचिंग दिस वीडियो। प्लीज़ वीडियो को लाइक कीजिए, शेयर कीजिए और मेरे चैनल लर्न फिजिक्स को सब्सक्राइब कीजिए। थैंक यू।